Hello, my name is Michael. Today is November 17th, and I'm recording this presentation on the XC-util supply chain backdoor discovered in March 2024, tracked as CVE 2024-3094. I chose this topic because it perfectly demonstrates multiple CS50 cybersecurity concepts in action, and shows how a single individual's vigilance can prevent a catastrophic global security incident. Before diving into the attack, let's understand what XC-utils is. XC is a compression utility that's installed on virtually every Linux system, similar to how zip works on Windows. When you run commands like tar xf on a modern Linux machine, it's often using XC compression in the background. It's maintained by Lasse Collin, a single volunteer developer who has been working on it for over a decade. This is critical infrastructure running the internet, yet it's maintained by one person, a common pattern in open-source software that creates systemic risk. The attacker used the pseudonym Jia and spent over 2 years executing a sophisticated social engineering campaign. This wasn't a quick hack, it was a long con. Jia started by submitting legitimate, helpful patches to the project. They complained on mailing lists about slow development pace, seemingly advocating for faster progress. Gradually, they earned commit access. This is a textbook example of the social engineering we discussed in building trust over time to exploit it later. The backdoor was discovered almost by accident. Andres Freund, a Microsoft engineer, noticed that his SSH logins were lagging by about 500 milliseconds, half a second. That's it. That tiny performance anomaly made him investigate. He discovered malicious code hidden in test files that activated during the build process, injecting a backdoor into the compiled binary. The backdoor existed only in versions 5.6.0 and 5.6.1, released in February and March 2024. Here's the attack flow in simple terms. The attacker added a malicious script disguised as a test file. When you compile XC-utils, the build process runs this test, which secretly patches the resulting binary. The backdoor specifically targeted SSH, the service that lets administrators log in remotely. It intercepted RSA key verification, allowing the attacker to authenticate with their own private key while leaving zero traces in logs. This is a supply chain attack, compromising software before it reaches users. The affected versions were pulled into major Linux distributions testing and rolling release branches, Debian Unstable, Fedora Rawhide, OpenSUSE Tumbleweed, and Arch Linux. But critically, they didn't make it into stable, production releases. Had this gone undetected for another few weeks, it would have affected approximately 80% of Internet servers, providing undetectable remote access. This could have been the most widespread backdoor in history. This incident directly connects to our course material. First, supply chain security. We trust software maintainers implicitly, but trust is a vulnerability. Second, social engineering, the 2-year trust-building campaign. Third, cryptography, the backdoor specifically targeted RSA key verification, a core cryptographic primitive. And finally, defense in depth. Organizations that relied solely on SSH for security would have been completely compromised. The detection method is crucial. This wasn't found by automated security tools or AI. It was found by a human noticing a tiny performance degradation and asking why. This embodies the threat detection principles and forensics. The security mindset means questioning anomalies. A 500 milliseconds delay would seem trivial to most people, but Andres Freund had the trained intuition to investigate. This shows that technology alone isn't enough, we need humans with security awareness. So how do we prevent this? For developers of critical software, implement mandatory multi-person review. No single person should have unilateral commit access. Use reproducible builds so compiled binaries can be verified against source code. For organizations, pin critical dependencies to specific versions, don't auto-update from testing branches. Implement defense in depth. Never rely on a single security control like SSH alone. Use hardware security modules for your most sensitive keys. The key takeaway is that this was caught by one observant engineer, not a security department or automated system. The open-source community dodged a bullet that could have compromised global infrastructure. For CS50 students, the lesson is clear: security is everyone's responsibility. Question anomalies, understand your supply chain, and never assume trustworthiness. As future developers or security professionals, you'll be on the front lines of preventing the next XZ backdoor. Thank you.